Welcome students. In this video you will study various instructions which perform data transfer operations in 8085 microprocessor. In data transfer operation, a microprocessor copy data from the source location and paste it into the destination location. These locations can be a register, input-output device or memory. While the copying action, the contents of the source will not modify. In fact, there will be no change in any flags of 8085 microprocessor. These copy instructions are classified into 6 groups. So let's have a look. These are the instructions. In this video, you will study instructions from group 1 to group 4. Rest of the instructions you will study in my next video. So students, please subscribe the channel. Now starting with the move instruction. There are 3 types of move instructions in 8085 microprocessor. In the first category, the operands are the general purpose registers. So instruction is written as move RD, RS. These general purpose registers can be A, B, C, D, E and H, L. So for example, move A, B. In this instruction, the contents of register B will be copied into the accumulator. This instruction requires only 1 byte of the memory and only 1 machine cycle will be executed, and that is the opcode fetch machine cycle. In fact, opcode fetch machine cycle is the first machine cycle of every instruction, which requires 4 T states. In this instruction, the addressing technique is register addressing mode because both operands are general purpose registers. To know more details on addressing techniques, you can see my video on addressing modes of 8085 microprocessor. Now the next instruction is move RD, M. Here M is the memory whose address is given in the register pair H. So in this instruction, the contents of the memory location is copied into the destination register that can be any general purpose register. In this instruction, the second machine cycle is memory read because microprocessor is reading the memory location and copying the contents into its general purpose register. Here the addressing mode is register indirect because the operand address is indirectly specified in the instruction, and total T states are 7. The third instruction using the move opcode is M, RS. In this case, the general purpose register will be the source operand and the contents of this general purpose register will be copied into the memory location whose address is specified in register pair H. For this case, the second machine cycle will be memory write because now microprocessor is writing the contents from source register to the memory location. It also using the register indirect addressing technique. Next is MVI and LXI instructions. These instructions are using immediate addressing technique, which means the operand is directly mentioned in the instruction. The difference between the MVI and LXI instructions is that MVI deals with the 8-bit size of the data and LXI deals with the 16-bit size of the data. Now let's see the first instruction. The opcode is MVI and operands are the general purpose register and 8-bit data. In this instruction, the 8-bit data will be copied into this destination register. For example, MVI A 32 hex. So in this instruction, the 32 hex will be copied into the accumulator. This instruction is using 2 machine cycles where the second machine cycle will be memory read because microprocessor is reading this 8-bit data from the memory. And the second byte of the instruction is for 8-bit data. So the total T states will be 7. Next instruction is where 8-bit data is copied into the memory location whose address is given in the register pair H. Once again, this instruction requires 2 bytes of the memory, and here the third machine cycle will be the memory write because 8-bit data is written over to the memory location. Total T states will be 10. The example of this instruction is MVI M2A hex. The last instruction in this category is LXI, register pair 16-bit data. So in this case, this 16-bit data will be copied into the register pair. Students, note the point that the size of the destination and source operands should be same. So if the data size is 16-bit, so it will be stored in the 16-bit size of the register, and that will be the register pair for case of 8085 microprocessor. Let's see the example, LXI B2050 hex. In this case, this 2050 16-bit data will be copied into the register pair B, where C register will have this 50 hex number and register B will have 20 hex number. Or you can say that register C will have the lower byte of the 16-bit data and register B will have upper byte of the 16-bit data. Similarly, for the other register pairs like register pair D and H, here the second and third byte is for this 16-bit data, and here second and third machine cycles will be memory read. Total T states will be 10. Now the in and out instructions. These instructions are used where microprocessor is communicating with the IO devices. Let's see the first instruction. In this, the opcode is in and operand is the 8-bit port address. So microprocessor is reading the or taking input from this port whose address is directly given in the instruction and copying it into the accumulator. Microprocessor can communicate with IO devices via accumulator register only. So in this instruction, second byte is for this 8-bit port address and second machine cycle will be memory read, because user is providing this 8-bit port address into the memory and microprocessor is reading from the memory. Third machine cycle for this instruction is IO read, for taking input from this port and copying it into the accumulator. Total T states required are 10. Here the addressing technique is direct because the address of the operand is directly this address can vary from 00 hex to FF hex. Now the next instruction is out, 8-bit port address. Just the reverse section of the first instruction. So in this instruction, the contents of accumulator are copied into the port address which is mentioned in the instruction. So second byte is for this 8-bit port address and second machine cycle will be memory read, third machine cycle will be IO write, because now microprocessor is writing to the port with the contents of the accumulator. Next is LDA and STA instructions. Before understanding the instructions, let's see the LDA and STA opcodes. Here A letter is denoting the accumulator register, means operation is performed with the accumulator register. LD stands for the loading to the accumulator and ST stands for the storing from the accumulator. Now let's see the first instruction, LDA 16-bit address. So address is directly given in the instruction. So addressing technique will be direct addressing technique. Let us understand this instruction by the example. LDA 2050 hex. So in this instruction, this address contents will be directly copied into the accumulator. Let us suppose this is the memory and this 2050 hex memory location is holding a 16-bit number, for example 3A hex. So according to this instruction, this 3A hex number will be copied into the accumulator. So in this way, instruction will be executed. Now moving ahead, the second instruction is STA 16-bit address. Once again, address is directly given in the instruction. Here the accumulator contents will be copied into the mentioned address. For the LDA instruction, the second and third byte is for the 16-bit address and second, third and fourth machine cycles all are same, that is the memory read machine cycles. Total T states required are 13. For STA instructions, second and third machine cycle is the memory read because microprocessor is reading this 16-bit address, and fourth machine cycle will be memory write because accumulator content will be copied into the memory location. Now the next is LDAX, STX. The difference is this letter X. Here X is denoting that the size of the operand will be 16-bit. Now the first instruction is LDX. Operand is register pair B or D. In this instruction, the accumulator will be loaded with the memory location contents whose address is specified in register pair B or D. Let's see the example LDX B. This is the register pair B and which consists of register B and C. Now assume that register pair B is holding a 16-bit number. Let us suppose 3000 hex. So this 16-bit number will be treated as an address 3000 hex, and the content of this address or the memory location will be copied into the register A 3A hex. So address is indirectly given in the instruction. In this way, instruction will be executed. Now the instruction STX, here the operands once again register pair B or D. In this instruction, the accumulator contents will be copied into the memory location whose address is specified in register pair B or D. These instructions LDX and STX require only 1 byte of the memory for opcode. And in LDX case, the second machine cycle is memory read for reading the address of this register pair B or D and taking input from that the accumulator. Total T states will be 7 and register indirect addressing mode is used because address is indirectly given in the register pair B or D. Similarly for STX, 7 T states are required and register indirect addressing technique is used. In this case, second machine cycle will be memory write for writing the contents of accumulator into the memory location. LHLD and SHLD instructions. Let's once again understand the opcodes first. L stands for the loading, HL is the register pair, D is denoting the direct addressing mode. So load HL register pair with the contents of the memory location specified directly in the instruction. But the size of HL register pair is 16-bit and one memory location can occupy maximum 8-bit size of data. Then how is it possible to store the another byte of the data? So let's understand this instruction via example. So example is LHLD 2050 hex. So this is not a 16-bit number, this is an address. So let's once again draw the memory state. Here the address is 2050 hex. Now assume the contents at this location is 1A. So according to this instruction, this 1A will be copied into the register L. And for register H, increment this address by 1, 2051 hex, and let us suppose the content is 30. So this 30 hex number will be copied into the register H. In this way, instruction will be executed. SHLD 16-bit address, just the reverse action of the LHLD. Here the contents of HL will be loaded into the 16-bit address and 16-bit address plus 1. In LHLD case, the 4 machine cycles will be memory read for reading 16-bit address and loading the 16-bit address and 16-bit address plus 1 contents to the L and H registers respectively. Total T states required are 16. For SHLD, second and third machine cycles will be memory read for reading the 16-bit address and Fourth and fifth machine cycle will be memory write for writing the contents of HL register pair into the specified location. Let's see the frequently asked questions from the topic. Specify the contents of registers and memory locations as the following instructions are executed. So this is just an example. Instructions may vary. Next is, what is the second byte in the instruction in? It is the 8-bit port address of input port. Write an assembly language program to transfer a number from register B to port address F0 hex. You can write it using all the data transfer instructions. And the third one is comparison of the instructions. Students, I hope you like the video. So please subscribe the channel and share it. And if you have any queries, then write in the comment section. Thank you so much.